Hi, welcome. Today I'm going to be talking on feedback and feedforward control system. Now, the concept of these control systems are very easy. This is what happens. I'm going to use a very brief. I just drew out the diagram. Sorry that it looks a little bit rough, but I'm going to use a very simple explanation here. Now, let's say for example I have a tank, and I have salt, I have water, and normally I'm supposed to release a salt solution. Let's say my salt solution should be about let's say I want 10 meter cube of 10, okay, let's say 10 kilogram per meter cube of salt. Now, what is 10 kilogram per meter cube means? I need 10 kilogram of salt and 1 meter cube of water to form 10 kilogram per meter cube of salt solution. It's a very easy thing. Now, inside this salt place, I have my 10 kilogram ready. Okay. Now, from an external source, I'm the one performing the whole reaction. I'm pouring in water at 5 meter cube. I'm pouring in 5 meter cube of water. You agree with me that this 10 kilogram and this 5 meter cube of water will not form my 10 kilogram per meter cube of salt solution. So what feedback control system is telling you to do is that adjust the amount of water coming in so that you have 10 kilogram per meter cube of salt solution. Feedback control system is simply saying control the system to give you what you want. Now let's come back here to this diagram. Disturbances is also known as inputs. Disturbances means what is coming in. Now this is the process. My process here is the mixing of this salt and water together. That's the process I'm doing here. Normally it's supposed to give me my salt solution. Salt solution here is a control variable. You can call control variable output, okay, and I can call my disturbances as inputs. So what is happening here from this very straight diagram here? Inputs, you process it, gives you output. Now, but I know that this 5 meter cube coming in with my salt that is already inside here cannot give me 10 kilogram per meter cube. So what will I do? I would have kept in a device here that would measure the concentration of the salt. Just look at what is happening here. Now, this will measure the concentration of the salt. That's the measuring device I have here. Okay. After measuring it, it will take it to the feedback controller. I'll have a control system. Now that control system is in some systems you have it as a computer. It can be anything at all. So it takes it to the control system. Now in this case, the control system is me. I'm the one controlling the system. It's a very simple technique. I have something that will measure the concentration. When the concentration tells me, I am the feedback controller in this case. When it tells me, I just simply go back here. Let's say I'm using the tap to control my water. I go back to the tap and I reduce the volume of water to 1 meter cube. Now look at what happens here. Measuring device, that's your output, salt solution is measured, takes it to the controller, feedback controller in this case. From the feedback controller, it takes it to the valve. Now the valve is what determines as in how fast or how slow your reaction occurs, okay? So it takes it to the valve. The valve in this case was the tap, okay? Now after taking it to the valve reduces or increases the amount of this thing that you need, then takes it back to the process. From the process, you can now have your final product. Now if for example, maybe I reduce the tap, that's the valve here, and maybe it's now coming out at 3 meter cube. Do not forget, I need 1 meter cube of water. If it's coming out at 3 meter cube, after this measuring device has measured it, the process will repeat itself again until when I finally have 1 meter cube of water and 10 kilogram of salt to give me 10 kilogram per meter cube. So it's a very simple process. Your input is being processed. You should have your output, but something measures it, sends it to the feedback controller. The feedback controller then controls the amount of inputs that is supposed to come in, process it again, and you have a final output. Now that's feedback control system. Now notice something in order for you to be able to like recollect this more, from feedback, the back here, okay, the back statement here, meaning that is happening after the output is already out. From the back, this occurs from the back after the output has already occurred. Now from the hint I gave you, it's happening from the output. Feed forward in another case will be happening from the front. Now let's focus on feed forward now. So now I have feed forward reaction. We'll just call it FF. Now in feed forward, what happens is I have my disturbances or inputs, anyone you want to call it, it's fine. And I have the process occurring here. Okay, so I have the process and I have, forgive my writing please, I have my output. Now unlike the other one, you measure it after it has gone out by the output. Now from here, this is the disturbances. Okay, I can easily measure with a measuring device, MD mini measuring device. Now from the measuring device, then it goes to the controller, then from the controller, so in this case now you have feed forward controller. Okay, FF controller. So from the feed forward controller, I have the valve. As the valve will go through my whole process again for me. Now from the valve, it takes it back to the process. Now what does this mean? Now let's look at feed backward again. Feed backward, it measures it from the output. When it notices the mistake you've made, it opens or closes the valve, sends it to the process. Let's look at feed forward. What happens in feed forward is that even before I pour this water, okay, I'm still going to be using my salt water solution here. Before I even pour the water at all, if this is my salt water solution, okay, and I have my salt water solution here. I have 10 kilograms of salt in here. Don't forget, this is the process. The process is just mixing of salt. I have my 10 kilograms of salt inside here. Now I'm about to pour the water. This is the cup I'm about to use to pour the water. Okay, let's say this is about to be poured into here. Now, what feed forward will do is that from here, I would have kept a measuring device. Now I know that I need 10 kilograms per meter cube. Now I know I need just 1 meter cube of water to form this salt water solution. Okay. Now this particular one is known as set point. It's what we call set point. That's what you want to get. Now from here, my measuring device will measure the water. So I have measuring device. When it measures the water, if the water I have here, for example, is 5 meter cube, I know I need just 1 meter cube of water. So immediately I send it to the feed forward controller, and I said the feed forward controller in this case is me. I'm the one controlling what is happening. So I know that I need just 1 meter cube. After I've measured it, immediately I take it to the valve. That's, I open my tap, I adjust the water so that the water is now coming out at, this is the valve here. So I adjust it so that the water is now coming out at 1 meter cube. Okay. Now if the water is now coming out at 1 meter cube, I can now easily send it to the process, so that the process will give me my output. I want to go over this process again. I have my normal 10 kilograms of salt here. I need salt water solution of 10 kilograms per meter cube. I already have the 10 kilograms of salt here. Now the water I'm about to pour is 5 meter cube. Even before I pour the water at all, I would have measured it. Once I see that it's 5 meter cube, I take it to the feed forward controller. What the feed forward controller will do is it will adjust the water to 1 meter cube, reduce the volume to 1 meter cube, reducing it by opening or closing of the valve. After reducing it, I can now easily send it back here to this solution. When I send it here and I mix it together, I now have salt water solution coming out at 10 kilograms per meter cube. So it's like the exact opposite of feed backward control. Thank you very much. I hope you guys understood what I explained. If you have any questions, please do contact me. Bye.